Well, let's start first with soap.
Okay.
Remember last time we talked about soap and we talked about that fancy word called saponification.
Yes.
And basically, it's oils or grease plus an alkali or base. And then because this is insoluble in water,
Yes.
right? And then that goes here to soap, which is now, as we all know, soap is very soluble in water.
Yes.
Right?
Yes.
So with that in mind, it's quite easy to see we're going from insoluble, which is very difficult to clean. We put a base in here, which is something, it could be sodium hydroxide. It could be other things, potassium hydroxide, that type of stuff. And with that, we get something here that's very soluble. The same thing goes for cleaning any other surface. Remember we talked about last time about most of our cleaners are very alkaline, because most soils over here basically fatty acids, right? Fatty acids are on the acidic side on the pH scale. Remember we talked about that?
Yeah, absolutely.
So
yeah.
in terms of making all this happen, we then use, and soap's been made for millennia. You know, the Babylonians made soap. You know, the fats and the grease and the grime and stuff like that from animals and into the ash that was formed from fires.
Right.
You know, when rain fell, it started sudsing. And of course, they said, hey, we got magic here.
Yeah. And then they started to compact it or put it on in a powder maybe back in those biblical days.
Yes,
and
of course.
Yeah.
And then it rose, you know, where they started using olive oil in Italy in the 7th century and so forth, until it became straightforward with making soap for many centuries until, say, the First World War, when, of course, a lot of the materials weren't readily available, and of course, from there, we started synthesizing surfactants. We can come to that maybe another time.
Yeah, yeah.
But for now, you know, when we talk about cleaning, we're talking about moving things from soils, and not just grease and grime, because we spoke about that very often. But we're talking about even today, which is very vital. We talk about bacteria, viruses, you know, microbes in general, moving them away. And you need surfactants to do that, because these things are sticky. They stick to surfaces. So, that's what all happens. Now, cleaning is a process that takes a lot of energy.
Right.
You know, it takes mechanical energy. You know, our forefathers used to be hitting things on a stone next to the river. That's mechanical energy. We know, fast
When
forward.
I grew up, at the laundry tub, I had the little serrated
yes,
board that you had.
The washer board.
The washer board. That's what it was.
Just like your chest.
Yeah, exactly. All those 6-pack or 8-pack, I think it is.
Right? And you wash. That's mechanical energy.
Yeah.
Right?
Okay.
That helps clean.
Yes.
Of course, we tend to minimize that by using chemical energy, right? So if I have to do a circle, just to show you in terms of cleaning soils, say we had a circle like this, you can divide the circle up into sections. You can have mechanical energy here, beating the thing, scrubbing, moving
agitation,
things.
I guess.
Agitation.
Yeah.
You have chemical, and with the chemical energy, of course, you mitigate a lot of this sort of stuff.
Yes.
Right? And temperature, you heat things up, fats and oils. You can see if the temperature increases, it becomes more soluble and easier to move about.
So hotter water.
Hotter water.
Okay.
Right?
Yeah.
And of course, time. Time is very, very important.
Yeah.
If you had all week, you could certainly wash your jeans just by moving them around and just spraying good old-fashioned water. Right? But you don't have that much time. So you can move these things around with the amount of chemistry, the amount of temperature, the amount of time, and you can move that thing around. But most important, of course, is water, right? And everything stands on the water. The water is critical, and we can talk about builders and so on, but we could do this at a different time.
Yeah.
What aids the water in making more efficient, and what aids the water in making the water wetter to do this job, and that's where surfactants come to play and so forth. So we could touch on that some more, maybe in another time.
Yeah, we'll add those on the
we
next
could add those
webinar
things
is what
on,
we'll do.
and we could talk about surfactants and so on.
Yeah.
But mechanical energy, we used to call it the 3 T's: time, temperature, turbulence.
Yeah.
Mechanical, chemistry, and so forth.
Yeah.
So
yeah.